morning students. So today we will discuss about halogen family. So halogens are fluorine, chlorine, bromine, iodine, astatine and tennessine are the members of halogen family. So these elements, 17th group elements are also called halogens. So these halogens, so halo means salt and gens means bond. So this is the Greek word, it is derived from the Greek word. And so the elements of 17th group show greater similarity among themselves. So they are showing so many similar properties. So that much similarity is not found in elements of other groups of the periodic table. So 17th group elements show most similarity in all the properties. So and then occurrence. So occurrence of halogens. So if you see fluorine and chlorine. Fluorine and chlorine are fairly abundant while bromine and iodine are less. So here the first two elements fluorine and chlorine are abundantly present, but here iodine and bromine are very less. And here fluorine is present mainly in insoluble fluorides. So fluorine allotropes are, this is fluorspar, and here this is cryolite and this is the fluorapatite. These three are the here allotropes of the fluorine, means fluorine present in the environment as these substances. So and small quantities are present in the soil, river, water, plants and bones and teeth of animals. So our enamel and our bones also contain some water, also contain fluorine. And next, seawater contains chlorides, bromides and iodides of sodium, potassium, magnesium and calcium. So in seawater also the chlorine is present as the salts of the metals, magnesium, sodium, like that. So here then the deposits of dried up seas contain these compounds, sodium chloride, carbonate, and these are the, after evaporating in the seawater, the sodium chloride will be remained, and also carbonate, KCl, NgCl2, 6H2O. So means mainly seawater contain the chlorine. And then certain forms of marine life contain iodine in their system. So this is the existence of the halogen family. And here important atomic and physical properties of group 17. So these are the physical properties of group 17 elements. So this is atomic number, you know. Atomic number increases from top to bottom. And then atomic mass. So as we go down the group, atomic number increases means atomic mass also increases. This is the normal only. And electronic configuration, they are all having NS2 NP5 outermost electronic configuration. So this is the electronic configuration. Next, covalent radius. So radius from top to bottom increases. So here there is no decrease. It means here the normal trend follows. So 64, 99, 140 and 130 means atomic radius, covalent radius is also increasing. Next, ionic radius also increases, there is no exceptions. And ionization enthalpy also decreased from top to bottom. So if you see in kilojoules per mole, so this is also decreased. Next, electron gain enthalpy. So in electron gain enthalpy, so the first element fluorine contain minus, means 333 kilojoules per mole energy is released during the addition of electron. And here 349, if you don't consider magnitude, so if you see this minus symbol you don't consider, this value you compare, so which is having more electron gain enthalpy, chlorine is having more electron gain enthalpy. So this is only here different, and then it is decreased. So electron gain enthalpy of chlorine is greater than fluorine. So this is due to small size of fluorine. So we have seen in every group the first element is having almost small size. Because of that small size it is showing some anomalous behavior. So this is also anomalous behavior of fluorine. Due to its small size, there are inter-electronic repulsions are existed. So due to that inter-electronic repulsion, so fluorine is having small size, inter-electrons will have some repulsions. So if you add one more electron, so there is a repulsions between these inter-electrons and this electron. So here, due to these repulsions, the energy we have to give some energy. So means the total energy will be decreased. So this is the reason, due to inter-electronic repulsions, due to small size of fluorine, fluorine is having less electron gain enthalpy than chlorine. So this is the order of electron gain enthalpy. Chlorine greater than fluorine, then bromine and iron. So this is the important thing, electron gain enthalpy order. And then electronegativity. Electronegativity, there is no exceptions. 4.3.2 means it is decreased from top to bottom. Next, hydration enthalpy. So hydration enthalpy means during hydration the energy released is called hydration enthalpy. So due to small size, fluorine will be hydrated more and it will release more energy. So fluorine is having high hydration enthalpy and then decreased. So these are some properties. And melting point. So melting point, if you see, so this melting point is increased from top to bottom. So this is due to surface area. So there is a melting point is directly proportional to surface area. So if surface area increases, then the interactions will be, van der Waals forces will be increases. So here in between fluorine and fluorine, there are dispersion forces. They are called London dispersion forces. So dispersion forces are directly proportional to surface area and also directly proportional to atomic weight. So as here surface area increases, means iodine is a very bigger, means surface area may increases. So that's why it is having high melting point. So melting point increases from top to bottom, and then boiling point also increases top to bottom because van der Waals forces increases from top to bottom. That's why fluorine, chlorine are gases, and then bromine is liquid and iodine is solid. So that's why forces are means London dispersion forces are increasing from top to bottom. That's why the physical state also in iodine we will find solid state. And also density increases from top to bottom. And then X means bond length also increases from top to bottom. Then bond dissociation enthalpy. So this is important. So bond dissociation enthalpy, here high bond dissociation enthalpy is for chlorine. So and then if you observe the value, then bromine and then fluorine and then iodine. So if you bond dissociation, if you compare bond dissociation enthalpy, chlorine will have a more bond dissociation enthalpy and then followed by bromine and followed by fluorine and followed by iodine. So this you have to remember. So only electron gain enthalpy and bond dissociation enthalpy are having some differences. Remaining all properties will follow normal trend. And then, so we have seen all these properties. So if you see, so here physical properties. So halogens display smooth variations. Fluorine and chlorine are gases and bromine is a liquid and iodine is a solid. So just now only we have discussed. Their melting and boiling point steadily increase with atomic number. This also we have seen. And here, so these halogens, all halogens are colored. So all F2, fluorine, chlorine, bromine and iodine. So this will all halogens exhibit color. So this color is due to electron transition. So means electron is excited. So due to that excitation and de-excitation, so this will absorb energy in visible region. So that's why they will emit also visible region light. So that's why we are seeing the colors of these halogens. So fluorine is a yellow color and chlorine is a greenish yellow, and bromine is red, and iodine is a violet color. So these are the colors of halogens. So this color is due to electron excitation and de-excitation. And fluorine and chlorine react with water, and bromine and iodine are only sparingly soluble. Solubility of halogens also, chlorine will dissolve in water, and this will have some low solubility in the water, but they are soluble in chloroform carbon tetrachloride. So, and here one smaller enthalpy of dissociation of fluorine. So, bond dissociation enthalpy of fluorine is smaller when compared to chlorine and bromine. So, compared to that of chlorine. So, whereas bond dissociation enthalpy from chlorine onwards show the unexpected trend. So, this we have seen bond dissociation enthalpy order. Chlorine will have high bond dissociation enthalpy, and then bromine, and here then fluorine after iodine. So, a reason for this anomaly is relatively large electron repulsions among the lone pair of fluorine. So, due to electron repulsions and small size of fluorine, so bond dissociation enthalpy is very less. So, due to less bond dissociation enthalpy, fluorine is more participative in reactions. Chemically, it is more reactive due to less bond dissociation enthalpy. So, next chemical properties. So, oxidation state, they show variable oxidation state. So, here, the halogens exhibit -1 oxidation state. General oxidation state is -1, because if they get one electron, they will have octet electronic configuration. So that's why generally they show -1 oxidation state, and instead of -1, they also shows +1, +3, +5, and +7 oxidation state. So here, this is +1 oxidation state. So in ground state. In first excited state, they will show +3 oxidation state, and in second excited state, they will show +5 oxidation state, and in third excited state, they will show +7 oxidation state. So here, because of empty d orbitals, they will show different oxidation state by excitation of electron, and the maximum they can show which oxidation number? +7. +7 is the maximum oxidation state of halogen